Hello students, welcome back to the next video of Digital Communication Systems. Myself Kunjan Mittal Roy in the Department of Electronics and Communication in GEMTech Greater Noida. So in the previous videos we have covered the basics of digital communication, its need, its advantages and its block diagram, along with its properties, SNR, bandwidth, channel capacity, transmission mediums and so on. Now in this video we would be covering the next topic, which is analog to digital communication system, which is nothing but pulse code modulation technique. So what is pulse code modulation? It is basically a process of converting analog signal or carrier signal in accordance with the instantaneous values of the message signal. So the modulation, basic modulation means converting the properties of a message signal in accordance with the properties of the carrier signal. So the message signal is the signal which is to be transmitted or communicated over the long distances, and it has no data, but it is used for long distance transmissions. There are many modulation techniques according to which we can classify as analog modulation and digital modulation, where the pulse code modulation is a technique comes under digital modulation technique. So the pulse code modulation is a technique which is used to convert the analog signal into binary sequences, that is ones and zeros. So the output of a PCM system will always be a binary signal. So we can show the waveform of a PCM system output, where the sine wave is showing the input of a PCM system and the output of a PCM system is a digital signal which may have different magnitudes of time durations and pulse width, and the output is always in the binary form. So instead of a pulse train, the PCM produces a series of numbers or digits. Hence this process is called digital. So the digital word comes from the series of digits, binary digits. Each one of these digits through a binary code presents the approximate amplitude of the signal sample. The pulse code modulation, in the process of pulse code modulation, the message is presented by a sequence of coded pulses. The message signal is achieved by representing the signal in discrete form in both time and amplitude. So, in the basic elements of a PCM system, firstly, the transmitter section of a pulse code modulator consists of three blocks, which are sampler, quantizer and encoder. And these three blocks convert the analog signal into digital signal. And before these sections, the low pass filter is used prior to sampling, which basically avoids aliasing effect. At the receiver section, the regeneration of impaired signal is done. Regeneration of impaired signal means if there are any losses or error in the transmission path, so it would be overcome by regenerating the signal. And then decoding and the reconstruction of quantized pulse train is done. So at PCM receiver, the blocks are used to recover the original form of signal. So this is the block diagram of a typical PCM system. First of all, the analog signal is the message signal. This is passed through a low pass filter to make sure that there is no aliasing effect. And then the sampler. Sampler is a block which converts the analog signal into its in its discretized form, in its discrete form, in its discontinuous form. After the sampling, we use quantization, where the amplitude of the signal is discretized. And for each amplitude, different magnitudes or different codes are provided in the section of encoder. The output of the encoder is always a binary pulse train having number of zeros and ones. These pulse trains are transferred to the channel. Within the channel, there are regenerative repeaters which repeat the signal automatically after a certain distances so that the original meaning or the message of the signal is conveyed at the receiver. So after a certain distances within the channel, there are a number of repeaters or regenerative repeaters, and finally the signal reaches the receiver. At the receiver, the first block is regeneration circuit, which is used to regenerate the signal in order to overcome the losses and distortion or error that has occurred during the transmission. The decoder is the circuit which converts the binary digits into the analog numbers of a quantizer output. The reconstruction filter makes sure that the signal is within the desired band and this is basically a low pass filter, a band pass filter. This basically receives the analog signal which was the sampled signal was created by using sampler. And finally at the destination we receive the original analog signal. So the low pass filter eliminates the high frequency components present in the input analog signal, which is greater than the highest frequency of the massive signal. This is basically done to avoid the aliasing of the massive signal. Sampler this is the technique helps to collect the sample data at instantaneous values of massive signal so as to reconstruct the original signal. The sampling rate must be greater than twice the highest frequency component of the massive signal in accordance with the sampling theorem. Quantization, this is the next block after the sampling. The quantizing is a process of reducing the excessive bits and confining the data. The sampled output is given to the quantizer, which reduces the redundant bits and compresses the values. Encoder. After quantizer, the next block is encoder. The digitization of analog signal is done by the encoder. It designates each quantized level by a binary code. The sampling done here is the sample and hold process. These three sections, low pass filter, sampler and quantizer. Low pass filter will act as an analog to digital converter. Regenerative repeater in the channel path also regenerates the signal to compensate the losses or error in the signal. Decoder basically decodes the pulses and reproduces the original signals. Reconstruction filter after the D to A conversion is done by a regenerative circuit and decoder. Low pass filter is employed called as the reconstruction filter to get back to the original signal. Hence PCM circuit digitizes the given analog signal, codes it and samples it, and then transmit it in an analog form. This whole process is repeated in a reverse pattern to obtain the original signal. Now the information capacity or the channel capacity. So Hartley capacity theorem, I equal to KTB, where K is the Boltzmann constant, T is the temperature in Kelvin, and B is the bandwidth. This is given as the practical communication band limit. Then there is a limit to the amount of data that can be transmitted over a given channel, which is given by the channel theorem, Shannon's Hartley channel capacity theorem. It is given as 2b log base 2m, where m is the number of discrete levels. Thank you so much for this video. I would like to wind up here. Thank you once again.